In differential calculus, we have a method which we call chain rule, and chain rule is used when the derivative that we want to solve for involves two functions. Now, say that we have y equals a function of u, and u, which is equal to a function of x, and we are required to determine the derivative of y with respect to x. What we are going to do here is that we get the derivative of y with respect to u, and we also get the derivative of u with respect to x, and to solve for dy over dx, we're just going to multiply dy over du and du over dx. Now, the product of the two derivatives is now the derivative of y with respect to x, right? Or that would now be dy over du multiplied by du over dx to solve for the derivative of y with respect to x. Now, this is what we call the chain rule. So to illustrate this chain rule, let us have an example here. So we are given y equals x cubed minus 3x plus 5, and x equals 1/2 square root of t plus 3. Find derivative of y with respect to t. So the first thing that we need to do here is to determine first the derivative of y with respect to x, because dy over dt is the product of dy over dx multiplied by dx over dt. So if we're going to determine now dy over dx, then that is now equal to, right? So the derivative of x cubed, that is equal to 3x squared. The derivative of negative 3x would now be equal to negative 3, and the derivative of 5 is equal to 0. So this is now dy over dx. Now, let us solve dx over dt. But before we can solve dx over dt, let us convert this first to its fractional exponent. So that would now be x equals 1/2 multiplied by t raised to 1/2 plus 3. X square root of 3 was converted to t raised to 1/2 because it is in the form of power x raised to n. Thus, we can already solve for the derivative of this one because we know the formula for x raised to n. So the derivative of x with respect to t, that would now be equal to 1/2 multiplied by 1/2 t raised to negative 1/2, or that is 1/2 minus 1, plus the derivative of a constant that is equal to 0, right? So if we're going to recall the formula for x raised to n, the derivative of x raised to n, this is equal to n x raised to n minus 1 d of x, or the derivative of x with respect to x, or this is the general power formula, right? So dx over dt is now equal to 1/4 multiplied by t raised to 1/2 minus 1, so that is equal to negative 1/2. Or this is now dx over dt equals 1 all over 4 square root of t. Because if we're going to make negative 1/2 positive, this would be equal to 1 over 4 t raised to 1/2. And t raised to 1/2 is the square root of t, therefore that would now be our dx over dt. Right? Now, solving for dy over dt, so dy over dt, which is the product of dy over dx multiplied by dx over dt, this is now equal to 3x squared minus 3, so that is our dy over dx. So that's 3x squared minus 3 multiplied by dx over dt, which is equal to 1 over 4 square root of t. Right? So simplifying this one, we now have 3. So 3x squared minus 1 all over 4 square root of t. And if we're going to rationalize this one by multiplying square root of t both on the numerator and the denominator, the derivative of y with respect to t is now equal to 3 square root of t multiplied by x squared minus 1 all over 4 multiplied by t. This is now the derivative of y with respect to